Jai Hind to all. Today I am here to present the fourth video lecture on the subject Digital Signal Processing KEC 503. The topic of the lecture is linear and circular convolution. And I am Dr. Amit Garg, Associate Professor in EC Department of AKGEC. And in this particular video lecture, we will see what do you mean by linear convolution, what do you mean by circular convolution, what is the basic difference between linear convolution and circular convolution, what are the techniques by which we can find out the circular convolution between the given sequences, and first we will see how we will obtain the linear circular convolution for the given sequences using different methods, and then we will see how we will obtain the linear convolution between two sequences using the circular convolution. As this particular topic we are studying under chapter DFT. So in DFT, the property of DFT is only the circular convolution. So here we will see the methods for finding out linear convolution with the help of circular convolution only, because circular convolution is the property of DFT but not the linear convolution. Okay, so let us start with the difference between linear convolution and circular convolution. So which between circular convolution and linear convolution. So here we can see that while calculating linear convolution, the length of the input sequences can be different. Means both the sequences both the sequences must have of equal length before performing the circular convolution. And if both the sequences are not of equal length, then we have to make it equal by doing the zero padding. So this is our second point. So here because different length of sequences can be used, so zero padding is not required. But if the length of the input sequence are different, then zero padding is required, and we will perform the zero padding to the sequence wherever the length is less, so that both the sequences will be of equal duration or equal length. Here in case of linear convolution, there is no requirement like periodicity, so the input sequence need not to be periodic. And in circular convolution, it is must that at least one of the input sequence should be of periodic or extended. Means if it is not periodic, then we can make it periodic by doing its extension. And here also in linear convolution, the obtained output sequence is non-periodic. And here in circular convolution, the output sequence is periodic. The periodicity is same as that of the input sequence. Okay, so here we can see the output sequence will also be the periodic, because the input sequence is periodic. And here we can see the length of the output sequence will be greater than the length of the equal sequence. And here the length of the output sequence is same as that of the input sequence. So what about the length? What is the length? So let us suppose here in case of linear convolution, we are having two sequences. Let's say we are having two sequences, x1n and x2n. Let's say these sequences are, let's say 1, 2, 3, 4 and 1, 2, 3. Then the length of x1n is 4, length of x2n is 3. So for performing linear convolution, there is no requirement of zero padding. And the length of the convolved sequence, let's say convolved sequence is x3n, then the length of the convolved sequence will be 4 plus 3 minus 1, that will become 6. Okay, so this is the length of linearly convolved sequence. And what about the length of circularly convolved sequence? So for performing, we have to basically perform the zero padding. Okay, so now your new sequence x2n will become 1, 2, 3 and 0. So now in this case, length of x1n equals to again 4, and length of x2n will become 4. Okay, so length of the convolved sequence, let's say x3n, this will also be 4. So you can see the length of linearly convolved sequence will be the length of first sequence plus length of second sequence minus 1. And in case of circularly convolved sequence, we will first do the zero padding if the length of these sequences are not equal. to the sequence wherein number of elements are less and the length will become equal to the length of the both the sequences. Okay, so you can see the number of elements are greater in case of linear convolution. Okay, so this is about linear and circular convolution. Now we will see how we'll perform the circular convolution between two sequences. So there are three methods by which we can perform the circular convolution between two sequences. First one is graphical method or circle method. This is the by default method. This is the by default method for performing the circular convolution means. This is, you can say, default method. If no method is mentioned, then student should solve the question using this method only. Okay. Then matrix multiplication method and DFT-IDFT method or Stochasm method. It is also called Stochasm method. So this is the default method, and matrix multiplication method is the simplest to solve, and it is hardest to solve. But if we'll talk about the computational complexity of all these methods, then computational complexity large, computational complexity small, and this is the computational complexity moderate. Okay, so we will see these methods by some examples and how we will solve the circular convolution between two sequences using graphical method, matrix multiplication method or DFT-IDFT method. Okay, so now take an example. Let us suppose there are two sequences that are given as x1n equals to 1, 1, 2, 2 and another sequence is 1, 2, 3, 4. So we have to find out the circular convolution of these two sequences using the graphical method. Okay, so how we will represent it? This method is also called circle method, and these sequences, because we are finding out the circular convolution, so these sequences need to be periodic, so we are putting these sequences in form of circle. Okay, so the x10 is this, x11, x12, x13, the elements values are written in front of these sequence values. Okay, and this is the second sequence x2n. You can see this is 1, 2, 3, 4. Okay, now we have to perform the circular convolution. Okay, so circular convolution is the similar type, is similar as of your convolution, simple convolution operation. Okay, so this convolution operation consists of operations like folding, shifting, multiplication and addition. So all these operations will be performed over here also. Okay, so for folding this, we have to first of all finding out x2 of minus n. Let's say x2 of minus n and mod 4 because there are 4 elements in it. Okay, and how the mod function is defined? X2 minus n mod n can be written as x2 minus n plus n, and that can be also written as x2 n minus n. Okay, now we will put the value of n because capital N is 4, so we will put the value of small n from 0 to 3. So 0, 1, 2, 3. So you will write it x2 minus 0 mod of 4. So this value will become x2 4 minus 0, x2 4. And x2 4, because the sequence is periodic, so x2 0, x2 1, x2 2, x2 3 and x2 4 is again 1. So that will become x2 0 equals to 1. Then if you will see x2 minus 1, so x2 minus 1 is nothing but x2 3, and what is the value of x2 3? That is equal to 4. And x2 minus 2 mod 4 or x2 2, so you can see here x2 2 will become the 3, and similarly x2 1 will become 2. So in x2 minus n mod 4, you can see the first value is similar here, we will obtain similar value. Then x2 minus 1, because we are finding out x2 minus n, so x2 minus 1 will become, you can see here, equal to x2 3, so that value is 4. So you can see here the x2 3 is there. Similarly x2 minus 2 is x2 2, so again we can write it x2 2 over here, the value is 3. And similarly x2 minus 3 mod 4 is x2 1, so the value is 2, so here is 2. Now what we will do after drawing this circle, now we have done basically, we have done initially we have done the folding option, and because at n equals to there is no shifting required, so we will simply multiply the individual corresponding elements and then we will add it up. Okay, so here is the multiplication of x1n into x2 minus n mod 4. So you can see we will multiply the corresponding elements. This value is 1, and here 1 and 4, that will become 4, and then 2 and 3, that will become 6, and then 2 and 2, that will become 4. Okay, so this is how we will obtain the various multiplication of the corresponding elements. Now we will add it up. So now the product sequence, let's say this is x3n. So the first value that we are obtaining is x30. That will be equal to 1 plus 4 plus 6 plus 4. 1 plus 4 plus 6 plus 4, that is equal to 15. So the first circularly convolved value that we have obtained is 15 in this case. Okay. Now again we will find out the second value. So we will shift it up by 1 unit anti-clockwise direction. So this will become x2 1 minus n. So how we will obtain, because this is x2 minus n, so how we will obtain x2 1 minus n? We will shift it up anti-clockwise by 1 unit in time. So this will become, so this x21 will become 2, x20 equals to 1, x23 equals to 4, and x22 equals to 3. Okay, so this is basically x21 minus n, or the second sequence after folding of first sequence and shifting it by 1 unit in time. So we are having this value. Now we will multiply these elements with this one, these elements with this one. So here we can see x1n into x2 1 minus n mod 4. So now we can see here 2 into 1, 2, 1 into 1, 1, 2 into 4, that is equal to 8, and 2 into 3, that will become 6. So now we will add it up, 2, 1, 8, 6. So after adding it up, we will get the value 3, 8, 11, 6, 17. Okay. So this is how we are obtaining this. The value, again we want the third value. So we will again shift it up by 1 unit time. Either we will shift it up 2 unit in time, or we can shift it also in 1 unit in time. So we will get the values. These are the values, x2 2 minus n, and here is x1n into x2 2 minus n mod 4. So we are having these values. Again we will add up these values. So this is 3 plus 2 plus 2 plus 8, that will become 15. And then last value, because the length of the circularly convolved sequence will become 4, because both the sequences are of length 4. So first value is this, second value is this, and third value is this, and the last value, again we will shift it up by 1 unit in time in anti-clockwise direction. So here is 3, 2, 1 and 4. Then we will add it up. So then we'll multiply with x1n into x2 3 minus n. So the values are 4 plus 4, 3, 4, 2, and we will add it up. So we'll get the 38. So finally, circularly convolved sequence value is so x3n sequence that we want to obtain, which is the circularly convolved sequence of these two sequences, is 15, 17, 15 and 13. So this is your answer. So here we can see also analytically here, and you can see the same thing. x3m is the circularly convolved sequence, x1n into x2 m minus n mod n. So this is how we have calculated all these values. So I have already told you with this graphical method, and if you want to show analytical, if you want to show it by analytical means, then you can also represent it like this. Okay. But in graphical method, more important is that you will show it by graphically by using these circles. Okay. So this is the graphical method. Now second one method is the matrix multiplication, which is somewhat easier to calculate by the human. But if we'll talk about the complexity, this method is more complex. So let us suppose we have to find out or compute the circular convolution between x1n and x2n, where x1n and x2n are defined in terms of delta function. Okay, so if you know the delta definition, then delta function is defined, delta n is defined at n equals to 0 only, and otherwise it is 0. Okay, and delta n minus 1 is defined only at n equals to 1, delta n minus 2 at n equals to 2, n equals to 3, n equals to 4, like this. So based on this, we can find out our sequence. Okay, so this first sequence, if you will see at n equals to 0, it is only defined and all these values will become 0. So the value is 1. So first sequence is 1 at n equals to 0. And then at n equals to 1, the value of delta n is 0 and delta n minus 3 is 0. So again the value is 1. Third value at n equals to 2, you can see this is only defined. So this value is minus 1. At n equals to 3, this value is only defined. So this is the sequence. And the sequence x to n, this is defined at n equals to 0. So 1 minus delta n minus 2 minus delta n minus 4. So this is 0 minus 1 0 and 1. So this is the second sequence. Okay. Now how we will calculate the circular convolution using matrix multiplication method. So what we have to do basically, we have to simply make a matrix. First of all, we can see here the number of elements are 5, length of x2n is 5 and length of x1n is 4. So we have to make its length is equal to 5 again. So your new x1n will become 1, 1, minus 1, minus 1 and 0. Now how can we calculate it? We can simply calculate it by, we will take one of the sequence and we will take one of the sequence as, and with the help of that sequence we will make a matrix and we will take another sequence as it is. Okay, so here you can see we have taken the second sequence. Sorry, yes, we have taken the second sequence here. Okay, so you can see your second sequence is 1, 0, minus 1, 0, 1. So we have written this sequence in a column of a matrix 1, 0, minus 1, 0, 1. Then we will repeat it up. We will cycle it. We will like this element will come here and all these elements will be like this. Okay. So 1, 1, 0, minus 1, 0. And similarly, again, this element comes over here and like this. Okay. This element comes over here. And all the elements will be like this. This element comes over here and all the elements will be like this. Now you will see, if you will again cycle, if you again rotate it, then again you will get the same sequence value. And so it will end it up over here and you can see because the number of elements are 5. So you are having a 5 by 5 matrix by doing this. And another sequence is 1, 1, minus 1, minus 1 and 0. So this is the second sequence. Now we have to, what we have to do, we have to simply perform the matrix multiplication here. Okay, and after matrix multiplication, we will get the final result and this is nothing but the circularly convolved sequence. This is nothing but the circularly convolved sequence. So you can see here 1 cross 1, 1 plus 1 cross 1, 1 and then minus 1 cross minus 1, that is again 1. So that this value is 3. So similarly, we can calculate all the values. So this method is very much appropriate if you want to just find out the circularly convolved sequence value. And you can easily find out the circularly convolved sequence value using this method. So this is the final answer. And here x3n is the circularly convolved sequence. Okay. So this is about your matrix multiplication method of finding out the circular convolution. Then we will see the third method, which is called DFT-IDFT or Stochamp's method. So if we will solve it manually, then this method is tedious, you can say. But if this will be solved by the machine, then this method is a very simple method. Like algorithm is very simple. Okay. So we'll see the algorithm for DFT-IDFT method. What we have to do, we are having two sequences, x1n and x2n, two sequences given. Let's say x3n is the circularly convolved sequence. So what we have to do, we have to first calculate x1k, which is nothing but the DFT of x1n. Then you have to find out x2k, which is nothing but the DFT of x2n. Then you have to find out x3k, which is nothing but the multiplication of x1k into x2k. Once you will find out x3k, then you can easily find out x3n by taking IDFT of x3k. So this is the simple algorithm by which we can calculate the circularly convolved sequence. Okay. So now take an example. Let compute circular periodic convolution of the two sequences. X1n is given 1, 1, 2, 2 and X2n is 1, 2, 3, 4 using DFT-IDFT method. It is also called Camps method. Okay. So first of all, sequence X1n is given, which is 1, 1, 2, 2. Okay. So we will find out xk or x1k, which is nothing but summation n equals to 0 to n minus 1 x1n into e to the power minus j 2 pi n k by n. You can see the length of the sequence L is 4. So we have to perform a 4-point DFT. So the value of k is given going from 0 to n minus 1. It means 0, 1, 2, 3. K is going from 0, 1 to 3. Also here it is n is 4 basically. So this will become 0 to 3. Okay. So we will see the various values. So for n equals to 4, we can write it this x1k equals to summation n equals to 0 to 3 x1n into e to the power minus j 2 pi nk by n, where capital N is 4 and the value of k is varying from 0 to 3 because 0 to n minus 1 is 0, 1, 2 and 3. Okay. So now for k equals to 0, put the value of k equals to 0 in this equation. So you can see here k equals to 0. When you will put k equals to 0, this term will become 1. And then you will put the value of n from 0 to 3. So the values are like x10 plus x11 plus x12 plus x13. Now we will add it up. You will get the value 6. Okay. Now for k equals to 1, if you will put the value of k equals to 1, so you will get the equation summation n equals to 0 to 3 x1n e to the power minus j 2 pi n by 4. It means e to the power minus j pi n by 2. Okay. Now you will put n equals to 0 to 3 in this equation. So you will get x10 plus x11 e to the power minus j pi by 2 plus x12 e to the power minus j pi plus x13 e to the power minus j 3 pi by 2. Okay. So the values of x10 is 1. X10 is 1. You can see from here the value of x10 is 1. This is 1. X11 is 1. So this will become 1, then 2, then 2. Now e to the power minus j pi by 2 is cos pi by 2 minus j sin pi by 2. E to the power minus j pi is cos pi minus j sin pi. And e to the power minus j 3 pi by 2 is cos 3 pi by 2 minus j sin 3 pi by 2. The value of e to the power minus j pi by 2 is minus j. The value of e to the power minus j pi is minus 1. And value of e to the power minus j 3 pi by 2 is j. Okay. So the value that we will obtain is minus 1 plus j. Similarly, we will calculate the same for k equals to 2. Then we will get the value 0. And for k equals to 3, we will get the value minus 1 minus j. So by this manner, we have obtained the value of x1k as 6 minus 1 plus j, 0 and minus 1 minus j. So this is how we have calculated the value of x1k. Now similarly, we can calculate the value of x2k by taking the 4-point DFT of sequence x2n. Only values are different, otherwise these things are same. So similarly for x2n equals to 1, 2, 3, 4, here n equals to 4, again the same formula will be there. And we have obtained the value of x20 as 10, x21 as minus 2 plus j2, x22 as minus 2 and x23 as minus 2 minus 2j. So you can write it like x2k will become 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Okay. So this is how you will calculate x2k for the second sequence x2n equals to 1, 2, 3, 4. Same procedure will be there, only the values are different. So now we have obtained x1k and x2k. Now we have to find out x3k. So x3k is nothing but x1k into x2k. So if you will see here, if you will calculate the value of x30, this will become nothing but x10 into x20. What are the values that we have obtained for x10 and x20? x10 is 6 and x20 is 10. So this value will become 60. Similarly, if you want to calculate the value of x31, this will become x11 into x21. So x11 is minus 1 plus j and x21 is minus 2 plus 2j. Okay, if you will multiply it, you will get the value minus 1 plus j into minus 2 plus 2j, that will later turn on minus 4j. So this is x3k. This is how we have calculated the value of x3k, and x3k for x30, x31, x32, x33. When you will obtain all those four, you will get this x3k. Now, once you will obtain x3k, then we can obtain x3n, which is simply the IDFT of x3k. So according to the IDFT definition, the formula is x3n will become 1 upon n summation k equals to 0 to n minus 1 x3k e to the power j 2 pi nk by n, and here the value is varying from n equals to 0 to n minus 1, that will become 3. Now you know the value of x3k. So with the help of values of x3k, you can find out the value of x30, x31. So you can see here x30 is 15, x31 is 17, x32 is 15, and x33 is 13. So this is the same question that we have taken in case of graphical method. So this is the circularly convolved sequence. Okay. So this method is somewhat tedious to be solved with the help of you can say copy pen. Okay. Otherwise, by any computer algorithm, it is the algorithm is quite simple. Okay. So this is how we have calculated the circular convolution. Now we have to find out the linear convolution using circular convolution. Okay. So it is to be noted that the resulting sequence obtained by both linear convolution and circular convolution have different values and length. Linear convolution results in an aperiodic sequence with a length of 2n minus 1, whereas circular convolution results in a periodic sequence with a length of n. Okay, so circular convolution will produce the same sequence values as those produced by linear convolution if zeros are padded at the end of the two given sequence x1n and x2n. Okay, so after zero padding, similar methods, that is graphical matrix, DFT-IDFT, can be used to obtain linear convolution as was used for circular convolution. So here we can see how we will calculate it. We will see it by one of the examples. Okay. So let us suppose we are having two sequences hn and xn. The value of hn is 1 to 4, let's say, and xn is 1 to. Now we can see the length of the first sequence is 3. So here n1 equals to 3. The length of the second sequence is 2. So n2 equals to 2. And we know the length of this linearly convolved sequence is the length of first sequence plus length of second sequence minus 1. So this value will become n1 plus n2 minus 1. So this will become 4. It means the length of the linearly convolved sequence will become 4. And we know if we want the output sequence length as 4 using circular convolution, then each of the sequences is of length 4 only. Okay. So what we will do, we will make these sequences length equal to 4, and then we will apply the circular convolution on it, and the resultant value of newly padded sequences that will give us the circular convolution sequences of new sequences is equivalent to the linear convolution of the old sequence. Okay. So appending zeros to the above sequences, so we will add it up zeros. So here we will add 1 0 because then this length will become 4, and here we will add 2 zeros. So the new sequences hn and xn are 1 to 4 0 and 1 to 0 0. Okay. Then using matrix method, now you can apply any method like matrix method, graphical method, or DFT-IDFT method. So here I am just showing that how we will obtain the linear convolution result. So I am using the matrix method because it is the simplest one. Okay. So here we will take sequence, let's say first sequence. With the help of the second sequence, we are making a matrix, and with this particular sequence we will multiply it. Okay, so this 1 2 0 0, then second sequence 0 1 2 0. How we are making like similar manner. Okay, so we will make this matrix, and you know the length of the sequence is 4. So the matrix obtained is 4 by 4 matrix, and then we will multiply it by 1 2 4 0. Okay, so we will get the value 1488. So 1488 is what? This 1488 is the circular convolution of these two sequences. We have applied circular convolution on these sequences, which is the newly padded sequences. So you can say this is the circular convolution of newly padded sequences, which is equivalent to the linear convolution of the old sequences. Okay, so this is the answer 1488. Here, after the sequence are padded, the sequence values obtained by circular convolution is the same as those produced by linear convolution. Okay, so this is how we can obtain the linear convolution using circular convolution. Another aspect is sectioned convolution. Here we can see that in case of linear convolution, if one of the sequences of infinite duration or very long sequence, then you can see this can be done using sectioned convolution. So sectioned convolution consists of two types of method. One is overlap save method and overlap. Another one is the overlap add method. Okay. So what we will do, how we will do in this section convolution? In the section convolution, what we will do, we will divide the input data which is of very long sequence into smaller number of subsequences, and then we will convert that subsequences with the impulse response of the system to obtain the final linearly converted sequence. Okay. So here, because of time, I am ending it up. Okay. So here are the references: Digital Signal Processing by S. Sullivan, 3rd edition, Digital Signal Processing by John J. Prokes. Thank you.